Space is silent and mostly empty. For centuries, our understanding of the cosmos was confined to the objects trapped here with us, orbiting our sun. That changed in 2017. On October 19, 2017, the Pan-STARRS telescope detected Oumuamua. It was the first object ever confirmed to have originated from outside our solar system. But it was discovered late, as it was already leaving, moving faster than the sun's gravity could ever hold. And it was strange. It was dark, reddish, and highly elongated. Most unsettling was its motion. It accelerated away from the sun, a non-gravitational push that could not be explained by the typical outgassing of a comet, because we detected no coma, no gas, no dust, just a push. This anomaly forced science to stretch. Was it a pure hydrogen iceberg, invisible to our instruments? Was it a cosmic dust bunny, a fluffy aggregate so light that sunlight itself, radiation pressure, pushed it? Or as one hypothesis infamously proposed, was the anomalous acceleration caused by the architecture of the object itself? Was it a solar sail? The alien probe hypothesis was born from this vacuum of data. Oumuamua was gone too fast, observed for too few days to settle the debate. It left a profound and uncomfortable question mark hanging over planetary science. It was an anomaly we couldn't solve. It was a test we had failed. Now, we have a second chance. This is 3IATLAS. Discovered with ample warning, it is also on a hyperbolic trajectory, a refugee from another star. But unlike Oumuamua, 3IATLAS is arriving. We are tracking it on its way in. This object is not just a scientific curiosity, it is an opportunity. The ambiguity of Oumuamua established a radical, low-probability hypothesis, that of an artificial interstellar artifact. That idea, once relegated to fiction, now has a file. It is the hypothesis of last resort, the one you only consider when all natural explanations have failed. The arrival of 3IATLAS is the perfect stress test for this very idea. We finally have an interstellar target in our sights. With our most advanced instruments ready, we have the James Webb Space Telescope, Hubble, and a fleet of assets orbiting Mars, including ESA's ExoMars Trace Gas Orbiter and NASA's MRO, all waiting for the object's crucial flyby in October 2025. This time, we will not be left with ambiguous data. This time, we will not be forced to guess. The probe hypothesis is testable. It makes predictions. And with 3IATLAS, we are about to run the experiment. The question is no longer, what was Oumuamua? The question is, what is 3IATLAS? And to answer that, we must first define the observations that would decisively separate a natural messenger from an artificial one. We must define the burden of proof. Before we can identify the unnatural, we must first rigorously define the natural. Before we can hunt for the artificial, we must exhaust the natural. If 3IATLAS is just a comet, it must behave like one. A comet is a dirty snowball, a loose aggregate of ice, dust, and rock from the dawn of a star system. As it approaches our sun, the radiation heats it, causing those ices to sublimate, turning directly from solid to gas. This gas erupts from the surface, creating a vast, glowing atmosphere called a coma. This is the first expectation. We are already watching this happen. Early observations from Hubble and JWST confirm 3IATLAS has a coma. That alone makes it fundamentally different from Oumuamua. The second test is chemistry. This gas is a chemical fingerprint. Testable predictions. If it's a typical comet, we expect its spectrum to be dominated by water, H2O, seen as its breakdown product OH, and, especially in the cold outer system, carbon dioxide, CO2. We also look for other signatures, like cyanogen, CN, When excited by sunlight, the carbon molecules, C2 in this gas, can create a beautiful, eerie green glow known as swan bands. Early spectroscopic data is coming in. The coma appears to be, as expected, rich in CO2. It shows signs of OH. This is the baseline. This is normal. But science lives in the anomalies. Tucked into the early, unverified data are curiosities. Reports of spectral lines for nickel, but without the corresponding lines for iron. In our solar system, these elements are almost always found together, forged in the hearts of stars. A natural object shedding pure nickel is deeply strange. Is it a fragment of a truly exotic metal-poor star's core, or is the data simply noise? This is where media hygiene is paramount. A single, unconfirmed report is not a discovery. It is a target for verification. In the age of instant analysis, it is vital to distinguish between institutional delays, the necessary, rigorous process of cross-checking data from different observatories, and a coordinated silence. There is no conspiracy. There is only the scientific method, which is slow, disciplined, and skeptical by design. We must also be careful with geometry. As 3IATLAS gets closer, we may see a sunward spike of dust, an anti-tail. This looks unnatural, a spear pointing at the sun, but it is a perfectly understood illusion, a plausible mechanism where we are seeing dust particles in the object's own orbital plane. So far, 3IATLAS is mostly behaving like a comet, but mostly is not a satisfying answer. The object is still far out. Its true character will be revealed as the heat increases, and as it passes the first gauntlet of our observers. The object is now threading the needle. It is early October 2025, and 3IATLAS is making its closest pass not to Earth, but to Mars. And at Mars, we have a welcoming committee. On or around October 3rd, 2025, the interstellar object will be close enough for our Martian assets to become frontline observers. This is our first opportunity for a close-up, high-resolution look. We have a fleet waiting. NASA's MAVEN is there to study how the solar wind interacts with the comet's coma, effectively tasting its plasma environment. ESA's ExoMars Trace Gas Orbiter, TGO, will use its powerful spectrometers to get an independent, close-range chemical fingerprint of the gas. But the crown jewel of this encounter is NASA's Mars Reconnaissance Orbiter and its HiRISE camera. HiRISE is a telescopic lens in orbit. It is capable of resolving the nucleus of 3IATLAS, not as a point of light, but as a place. We are testing the object's morphology. If 3IATLAS is natural, we predict HiRISE will see an irregular, potato-shaped, dark, and cratered body, much like other cometary nuclei we have visited. We expect to see distinct jets of gas and dust erupting from active regions on its surface. An anomalous observation, a failure of the natural model, would be unambiguous. A nucleus that is geometrically perfect, a surface that is smooth, uniform, or highly reflective. Any clear indication of artificial structure. This is the first test of form. Even the rovers on the surface, Perseverance and Curiosity, may look up, attempting to capture a faint streak in the thin Martian sky. This flyby is a critical, coordinated campaign. It gives us our highest resolution data before the object moves on. After this encounter, 3IATLAS continues its plunge. Around October the 21st, 2025, it enters solar superior conjunction. From Earth's perspective, it will be lost in the sun's glare, blinding our most powerful telescopes like Hubble and JWST. During this blackout period, the only new information we will have is the priceless data packet traveling from our Mars orbiters back to Earth. As the Deep Space Network locks on, the first HiRISE images will load. In one moment, we will see the object's face for the first time. Will we see a familiar, chaotic snowball? Or will we see something that requires a new explanation? The object has passed through the fire. In late October 2025, 3IATLAS reached perihelion, its closest and most violent encounter with our sun. For weeks, it was lost to us, invisible in the solar glare. Now, in December, it has reappeared. It is moving outbound, fast, never to return, and this is when the most critical test begins. We are no longer just looking at it, we are weighing it. This is the test of thrust. It is the ghost of Oumuamua. The Oumuamua anomaly was simple. It accelerated. This, by itself, is not strange. Comets do this. As the sun heats them, ice explodes from their surface. These jets of gas act like natural, chaotic thrusters, pushing the comet's nucleus. This is non-gravitational acceleration. It is an expected and well-understood part of cometary mechanics. This natural mechanism gives us a direct mathematical test. If the object is a comet, there must be a direct relationship between cause and effect. The cause is the outgassing. The effect is the thrust. We can see the cause. We can measure the coma's brightness and spectrum to determine how much gas and dust is being expelled and in what direction. We can also see the effect. We can use a global network of telescopes to measure the object's orbit with exquisite precision, detecting the slightest deviation from a purely gravitational path. The test is simple. Does the cause match the effect? If 3IATLAS is a comet, its observed acceleration must be fully explained by the volume of material we see it venting. The scales must balance. The alien probe hypothesis predicts a failure of this balance. It predicts an unexplained thrust. It predicts we will measure a significant change in its orbit. But when we look at the coma, we will find too little gas to account for the push. This would be a profound discovery. It would be a black box engine. Propulsion without a visible natural propellant. It would be Oumuamua all over again, but this time with high-resolution data. As it sails past the orbit of Mars and heads for its rendezvous with Jupiter's gravity on March 16, 2026, we will be tracking its motion every single night. Is it a simple snowball pushed by steam, or is it something else, pushed by forces we do not yet understand? We have tested its form. We have tested its motion. Now we face the final and most profound test. This is the test of intent. Comets are fragile. They die. As they fly through the solar system, the repeated cycle of heating and cooling creates immense thermal stress. Sometimes they simply fall apart. We saw this spectacularly with Comet Shoemaker-Levy 9 in the 1990s. Jupiter's gravity tore it into a string of pearls, more than 20 fragments that subsequently and chaotically smashed into the planet. If 3IATLAS is a natural comet, its fragmentation will be similarly chaotic. If it breaks apart, we will see a cloud of debris, all tumbling, all outgassing, all sharing the same basic orbital path. This is the natural, expected outcome, but the artificial probe hypothesis makes a far more radical prediction. What if 3IATLAS is not a single object, but a transport? What if its purpose is not to visit, but to deliver? The decisive observation would be this. We observe the nucleus release a secondary object, but it is not a chaotic tumble. It is a clean separation. And then we observe that secondary object maneuver. This is the non-negotiable line. This is the difference between fragmentation and deployment. It is the Oumuamua thrust test, but with a control group. We would have two objects to track, the main body, Object A, and the new fragment, Object B. We would run the test on both. We would see Object B, the deployed probe, fire a thruster. We would see its trajectory change, independently of the main nucleus. it would begin to follow its own new orbital path. Then, we would point the James Webb Space Telescope at this new object. We would take its spectrum, and in the most profound, terrifying, and conclusive observation in human history, we would find nothing. No coma, no gas, no dust. We would observe pure anomalous thrust, propulsion without a visible natural propellant, the signature of an engine. This single observation, a coordinated maneuvering fragment with no coma, would be impossible to reconcile with any known natural phenomenon. It would be the definitive, unambiguous, and paradigm-ending proof. It would be the answer. This is the burden of proof. It is the single most important concept in science, and it has never been more relevant. An extraordinary claim requires extraordinary evidence. The claim of an alien artifact is the most extraordinary one we can make. Therefore, the evidence must be overwhelming. It must be irrefutable. What does that evidence look like? It is a pyramid. At the base, anomalous chemistry like the nickel-iron discrepancy. This is interesting. It is a puzzle, but it is not proof. It is a signpost pointing to a new class of natural object. Above that, anomalous morphology. If the high-rise images reveal a geometric shape, that is baffling. It is a deeper puzzle, but it is not proof. We have never seen an interstellar object up close. Perhaps nature builds them in ways we have not imagined. Higher still, anomalous thrust. This is the Oumuamua test. If we find the object is accelerating without a visible natural propellant, this is a profound paradox. This is where science stops and says, our models are broken. This is the first truly powerful line of evidence. And at the very peak of the pyramid, anomalous behavior, a coordinated, maneuvering, coma-free fragment. This is the only test that is conclusive. It is not a puzzle, it is not a paradox, it is a demonstration. It is falsifiable, it is definitive, and it is impossible to explain with our current understanding of physics and nature. This is the standard, and this evidence cannot come from one place. It must be replicated. If JWST sees anomalous thrust, Hubble must see it too. If the TGO sees a strange spectrum, ground-based telescopes must confirm it. A signal seen by one instrument is an anomaly. A signal seen by all instruments at the same time is a discovery. In science, we are not here to find what we are looking for. We are here to understand what we are seeing. The alien probe hypothesis is not a goal. It is a last resort. It is a box we keep locked, and we only open it when we have proven beyond all doubt that every other box is empty. As 3IATLAS leaves our system, it will be gone forever, but it will leave its data behind. It leaves a set of numbers in our computers, trajectories, spectra, images, and those numbers will tell a story. Our job is not to fearmonger. Our job is to be disciplined, to be skeptical, and to be ruthlessly objective. Our job is to see if that story can, by any stretch, be a natural one. The greatest discovery in human history will not be announced in a panic. It will be announced in a peer-reviewed paper after years of verification, with a conclusion that simply states, we have exhausted all natural explanations. The object remains unexplained.